And now in this lecture we'll find out the area of the green shape. In the drawing we have a quarter circle. OAB is a quarter circle, and we also have here tangent QP is tangent to the quarter circle here at this point. And we know that side AP, this side AP equals to 6 units in its length, side BQ equals to 3 units in its length. This is angle BQP, that is a right angle, and this is also angle APQ, that is also equal to 90 degrees in its size, and our mission is to find out the area of this green shape. Okay, so first of all we will define the point of tendency of tangent QP with this quarter circle. This point is point S. And we join points O and S together by a straight line. Point O is the center of the quarter circle. Point S is the point of the quarter circle itself. Therefore OS is the radius of this quarter circle. We will define the radius of the quarter circle as X. X is the radius of the quarter circle. So OS equals to X, it is the radius of the quarter circle. In the next step, we'll do a construction. That is to say, from point B, we'll draw perpendicular on the radius OS. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point B and OS as point M. We have the radius OS, of this quarter circle that is equal to X. The radius OS is drawn to point S, that is the point of tendency of tangent QP in this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent QP will be perpendicular to the radius SO. If QP is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. In the next step, we'll focus on this quadrilateral BMQS. Inside this quadrilateral BMQS, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of this fourth angle. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle must be equal to 90 degrees in its size. So quadrilateral BMQS has 4 right angles. And you know that any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrilateral BMQS as a rectangle. And you also note that the opposite sides of a rectangle are equal to each other. That is to say, side BQ equals to side MS. BQ equals to MS, but BQ equals to 3, therefore MS must be also equal to 3. MS equals to 3 units in its length. We have also another rule. The rule is that the opposite sides of a rectangle are parallel to each other. That is to say, side BQ is parallel to the opposite side MS. So I write it down. So in rectangle BMQS, side BQ is parallel to side MS. According to the rule that the opposite sides of a rectangle are parallel to each other. OS is the radius of this quarter circle, is equal to x units. So OS is a radius, it is absolutely a straight line. And MS is part of OS. Again, MS is part of OS. And we know that MS is parallel to QS, the MS is parallel to BQ. And we know that if a part of a straight line is parallel to another straight line, then the whole straight line, then the straight line itself must be also parallel to the other straight line. Here, MS is parallel to BQ, therefore OS, that is the whole straight line, must be also parallel to BQ. So OS is parallel to BQ. OS is parallel to BQ. So in quadrilateral OBQS, in this quadrilateral, side OS is parallel to side BQ. Again, in quadrilateral OBQS, side OS is parallel to side BQ. So quadrilateral OBQS has one pair of parallel sides. Therefore, quadrilateral OBQS is a trapezoid. Okay, so quadrilateral OBQS is a trapezoid. Actually, the definition of a trapezoid is a quadrilateral that has one pair of parallel sides. And therefore, quadrilateral OBQS is a trapezoid. So, what is the length of this line segment OM? OS minus MS equals to OM. Again, OM equals to OS minus MS. So OM equals to OS, that is the radius of the quarter circle, that is x, according to our definition, minus ms, that is 3. In conclusion, we found out that OM, this side OM, is equals to x minus 3 units in its length. In the next step, from point A, we draw perpendicular on the radius OS. Again, from point A, we draw perpendicular on OS. So this angle is equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point A and OS as point N. So in the next step, we'll focus on this quadrilateral NSPA. Inside this quadrilateral NSPA, we have 1, 2, 3 right angles, and therefore the fourth angle must be also equal to 90 degrees. I will not repeat on all the process here. Here, the fourth angle must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equals to 90 degrees. The sum of the angles in any quadrilateral is equals to 360 degrees. So the missing fourth angle must be equal to 90 degrees in its size. Therefore, the quadrilateral ANPS, this quadrilateral has 4 right angles. So we can relate to this quadrilateral with 4 right angles as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ANSP, side AP equals to side NS. But AP equals to 6, therefore NS is also equals to 6. So NS equals to 6 units in its length. What is the length of line segment NM? NM is equals to NS minus MS. Again, NS minus MS equals to NM. NS minus MS equals to NM. So NM is equals to NS, that is 6, minus MS, that is 3. So Nm equals to 6 minus 3, that is 3. In conclusion, we found out that Nm equals to 3 units in its length. This small line segment Nm is equals to 3 units in its length. So what is the length of line segment ON? ON is equals to OS minus NS. Again, ON, the length of line segment ON is OS minus NS. OS minus NS. That is to say, ON equals to OS, that is the radius of the quarter circle, that is x, minus NS, that is 6. So in conclusion, we found out that ON equals to x minus 6. ON equals to x minus 6 units in its length. We have the rule that the opposite sides of a rectangle are parallel to each other. So in rectangle APSN, side AP is parallel to side NS. So I write it down. In rectangle APSN, side AP is parallel to the opposite side NS. AP is parallel to NS. AP is parallel to NS. Side AP is parallel to the opposite side NS. NS is part of OS. Again, NS is part of OS, and OS is the radius of the circuit is absolutely straight line. So we know that part of the straight line OS is parallel to the straight line AP. Part of the straight line OS, that is NS, is parallel to AP. So if a part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. Therefore, OS must be also parallel to AP. So if we know that OS is also parallel to AP, so OS is parallel to AP. So in quadrilateral OSPA, in this quadrilateral, we have one pair of sides that are parallel to each other. Side OS is parallel to side AP. Therefore, quadrilateral OSPA is a trapezoid because it has one pair of parallel sides. So quadrilateral NASP is a trapezoid. This quadrilateral APSO is a trapezoid. We can already found out that quadrilateral OBSQ is a trapezoid, and quadrilateral OSPA is also a trapezoid. Okay. In the next step, we will define this angle NOA is alpha. So in the right triangle ONA, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. This angle equals to 90 degrees minus alpha, and we will define that 90 degrees minus alpha is equals to beta. If 90 degrees minus alpha equals to beta, it means that 90 degrees minus beta is equals to alpha. So the missing angle here equals to 90 degrees minus alpha, and 90 degrees minus alpha equals to beta according to our definition. So the missing angle here equals to beta. This angle BOA, or angle AOB, this angle is the right angle, it is equals to 90 degrees. So the big angle AOB equals to 90 degrees. This angle equals to alpha, therefore the missing angle here must be equal to 90 degrees minus alpha, because this angle equals to 90 degrees and this angle equals to alpha, therefore the missing angle here must be equal to 90 degrees minus alpha. And according to our definition, 90 degrees minus alpha equals to beta. So this angle equals to beta, angle BOM equals to beta. So in the right angle OBM, this angle equals to 90 degrees, it is the right angle, this angle equals to beta, therefore the missing angle must be equal to 90 degrees minus beta, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So the missing angle here, that is angle OBM, equals to 90 degrees minus beta, but according to our definition, 90 degrees minus beta equals to alpha. Here, 90 degrees minus beta equals to alpha. So the missing angle here equals to alpha. Okay. So in the next step, we will prove that the right orange triangle OBM, this is the right orange triangle OBM, is congruent to the right blue triangle ONA. So we prove that the orange triangle is congruent to the blue triangle. So I write it down. We prove that the right orange triangle OBM is congruent to the right blue triangle ONA. So why the orange triangle is congruent to the blue triangle? First of all, those two angles are both equal to beta, therefore they are equal to each other. So this is angle POM in the right orange triangle, and it is equal to this angle, that is actually angle NAO in the blue right triangle. They are both equal to beta, therefore they are equal to each other. So I repeat again that angle POM in the right orange triangle equals to angle NAO in the blue triangle. They are both equal to beta, therefore they are equal to each other. In addition, those two angles, they are both equal to alpha, therefore they are equal to each other. So this is angle OBM in the orange triangle. And it is equals to this angle, that is actually angle AOM in the blue triangle. Repeat again. Angle OBM in the orange triangle equals to angle AOM in the blue triangle. They are both equal to alpha, therefore they are equal to each other. And finally, those two angles, they are both right angles, therefore they are equal to each other. So this is angle OMB in the orange triangle. And it is equals to this angle, that is actually angle ANO in the blue triangle. Repeat again. Angle OMB in the orange triangle equals to angle ANO in the blue triangle. They are both equal to 90 degrees, therefore they are equal to each other. What is the definition of line segment OB? Point O is the center of the quarter circle. Point B is the point of the quarter circle itself. Therefore OB is the radius of the quarter circle, that is equal to x according to our definition. Likewise, what is the definition of line segment OA? Line segment OA starts from point O, that is the center of the quarter circle, and ends at point A, that is the point on the quarter circle itself. This is exactly the definition of a radius. So OA is the radius of the quarter circle, that is equal to x. So those two sides, they are equal to each other. So side OB in the orange triangle equals to side OA in the blue triangle. They are both the radii of the circle, therefore they are equal to each other. So actually found out that the right orange triangle, triangle OBM, is congruent. This is the sign of congruent to the right blue triangle, triangle ONA, according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if you prove that two angles and the side that included between the two angles in one triangle are equal to the two angles and the side that included between the two angles in a second triangle, then you actually proved the two triangles congruent to each other according to angle side angle rule. And here we actually proved that those two angles, alpha and beta, and the side that included between those two angles, that is x, in the orange triangle, are equal to those two angles that are alpha and beta, and the side that included between those two angles, that is x, in the blue triangle. Therefore we proved that those two triangles can go into each other according to angle side angle rule. And from the fact that those two right triangles can go into each other, we will derive that side BM in the orange triangle, hence side BM in the orange triangle is equal to side ON in the blue triangle. And again, we derive that side BM in the orange triangle is equal to side ON in the blue triangle. According to the rule that corresponding sides in congruent triangles are equal to each other. So those two, the orange triangle and the blue triangle, can go into each other. Therefore, those two corresponding sides must be also equal to each other. So we have already found out that ON equals to X. ON, actually ON, what is the length of ON? ON is equals to OS, that is X, minus NS. What is the length of NS? NS equals to SM, that is 3, plus NM, that is 3. 3 plus 3 is 6. So ON in total equals to OS, that is X, minus NS, that is 6. So in total, ON equals to X minus 6. ON equals to X minus 6. And from this equation, BM equals to ON equals to X minus 6, we derive that BM is also equals to X minus 6. So this is side BM, and BM equals to X minus 6 units in its length. And again, because of the fact that those two triangles can go into each other, we will conclude from it that side OM in the orange triangle, side OM in the orange triangle is equal to side AN in the blue triangle. Side AN in the blue triangle and we just right now found out that OM equals to X minus 6. OM is equals to X minus 6. And from this equation, X minus 6 equals to OM equals to AN, we will derive that AN is also equals to X minus 6. AN equals to X minus 6. AN equals to X minus 6. So, in the next step, we will implement the Pythagoras theorem on the orange triangle, triangle ONA. Again, here OM equals to AN. But what is the length of OM? OM is equals to OS, that is X, minus MS, that is 3. So in total, OM equals to X minus 3. Here OM equals to X minus 3. And therefore, from this equation, X minus 3 equals to OM equals to AN. We derive that AN is also equals to X minus 3. Equals to X minus 3. So I'll copy the right orange triangle in a new page, and we will implement on this right orange triangle the Pythagoras theorem. So AN equals to X minus 3. And we already found out that ON equals to X minus 6. OA is the radius of the quarter circle, that is equal to X. So actually, this is the right orange, this is the right blue triangle ONA that I copied from the original drawing. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ONA is OA. Therefore, the square of the hypotenuse is OA squared, and it must be equal to ON squared plus NA squared. OA is X, therefore OA squared is X squared, and is equals to ON squared. ON is X minus 6. Therefore, ON squared is X minus 6 squared plus NA squared. NA is X minus 3, therefore NA squared is X minus 3 squared. So X squared equals to X minus 6 squared. X minus 6 squared equals to X squared plus 6 squared, that is 36, minus 2 times x times x, minus 2 times x times 6 is minus 12x, plus x minus 3 squared is x squared, plus 3 squared, that is 9, minus 2 times x times 3 is minus 6x. So here we have x squared in this side of the equation. We have x squared on both sides of the equation, so x squared will get cancelled. After we cancelled x squared, we have to be in this side of the equation 0. That is equals to 36 plus 9 is 45, plus minus 12x minus 6x is minus 18x, plus x squared. In conclusion, found out that x squared minus 18 x plus 45 equals to 0. So we have here a quadratic equation. And the solution to this quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Here a, b and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. In our specific quadratic equation, x squared minus 18x plus 45 equals to 0, the coefficient a equals to 1, the coefficient b equals to minus 18, and the coefficient c equals to 45. So we put the data inside this formula, and we will find out the value or the values of x. So according to this general formula, x will be equal to minus b. b is minus 18, so minus b is minus 18, that is plus 18, plus minus square root of b squared. b is minus 18, the square root of b squared is minus 18 squared, that is 324 minus 4 times a, that is 1, is minus 4, and minus 4 times 45 is minus 180 divided by 2a. a is 1, so 2 times 1 is 2. So x equals to 18 plus minus 324 minus 180 is 144. So inside the root we'll have to only with 144 divided by 2. So in conclusion, found out that x equals to 18 plus minus square root of 144 over 2. We have here two solutions that are possible for x. So x equals to 18 plus minus the square root of 144 is 12 over 2. Repeat again, we have here two solutions that are possible for x. X could be equal to 18 plus 12, that is 30, and 30 over 2 is 15. So the first solution for x is that x equals to 15, and the second solution for x is that x equals to 18 minus 12, that is 6, and 6 over 2 is 3. So the second solution for x, that x equals to 3 units. We found out that the length of line segment BM, this line segment BM, is equal to x minus 6. So x minus 6 is the length of a side. So as a length, it must be a positive number. So in conclusion, found out that x minus c must be a positive number, that is to say it must be greater than 0. You will add 6 to this inequality and we'll get that x minus 6 is greater than 0, so plus 6. So x must be greater than 6. And because of the fact that x must be greater than 6, x equals to 3 is less than 6. So this solution is the correct solution. We cancel the solution and we left only with the other solutions, that x equals to 15 units in its length. So what is the area of this green shape? The area of the green shape the green shape is equals to the area of trapezoid OBQS. This trapezoid OBQS, we already found out that quadrilateral OBQS is a trapezoid, so it is the area of trapezoid OBQS. Yes, it is the area of the green shape equals to the area of trapezoid OBQS plus the area of the other trapezoid, that is trapezoid OSPA. The area of this trapezoid OSPA. Again, it is the area of trapezoid OBQS plus the area of trapezoid OSPA. So the sum of the areas of those two trapezoids will give us the area of this big shape in total. We'll get the area of this shape OBQPA. The area of this big shape, and then when we subtract from the area of the big shape the area of this quarter circle, we get exactly the area of the green shape. So, and the area of the quarter circle equals to the area of the circle, that is pi x squared over 4. And again, the area of the quarter circle equals to the area of the circle over 4. The radius of the quarter circle is x, therefore the area of the circle is pi x squared over, and when we divide the area of the circle pi x squared by 4, we get the area of this quarter circle. So the area of this whole shape in total minus the area of this quarter circle will give us exactly the area of this green shape. Okay, repeat again, the area of trapezoid OBQS plus the area of trapezoid OSPA will give us the area of this shape in total, and the area of the whole shape minus the area of this quarter circle OBA will give us exactly the area of this green shape. And we know that the area of any trapezoid equals to the sum of its bases times the height over 2. Okay, so here we have OS is the radius of the quarter circle that is equal to x, and we already found out that x equals to 15. So it is OS plus BQ, that is 3. OS is 15, BQ is 3, so 15 plus 3 is 18. Times the height is BM, that is x minus 6. X is 15, so 15 minus 6 is 9. So it is times 9 over 2. So this is the area of this trapezoid OPQS plus the area of this trapezoid OSPA. The area of this trapezoid OSPA is equals to OS, the sum of the two bases, that is OS plus AP. OS is X, that is 15, plus AP, that is 6. So 15 plus 6 is 21 times the height. The height is AN, that is X minus 3. X is 15, therefore 15 minus 3 is 12. So it is 21 times 12 over 2. Okay, minus the area of the quarter circle, that is pi x squared over 4. So it is pi, x is 15, therefore x squared is 15 squared, that is 225 over 4. So the area of the green shape in total will be equal to we have here 18 over 2 is 9, and 9 times 9 is 81, plus 12 over 2 is 6, and 6 times 21 is 126, plus 225 over 4 times pi. 81 plus 126 is 207, minus 225 pi over 4, it is equals to 176 point 225 over 4 times pi. It is 176.714. So 207 minus 176.714, it is equals to 30.285 square units. In conclusion, we found out that the area of the green shape in total is equals to 30.285 square units. Repeat again. We actually found out that the area of this green shape is equals to 30.285 square units. So in the next step, I will summarize the lecture. In this lecture, we found out the area of this green shape. So in the drawing, we have a quarter circle. AOB is a quarter circle, and we also have here tangent QP, that is tangent to the quarter circle here at this point. In addition, we know that angle BQP, this angle is a right angle, and angle APQ, this angle, it is also a right angle. Side AP equals to 6 units in its length, side BQ equals to 3 units in its length. Again, our mission is to find out the area of this green shape. So, first of all, we defined the point of tendency of tangent QP with this quarter circle as point S, and we joined points O and S together by a straight line. Here, point O is the center of the quarter circle, point S is the point of the quarter circle itself, therefore OS is the radius of the quarter circle. We define the radius of the quarter circle as x, so x is the radius of the quarter circle here. And we have here rule 1 that we can implement. The radius OS is drawn to point S, that is the point of tendency of tangent QP with this quarter circle. And whenever you have a radius that is drawn to the point of tendency, then tangent QP will be perpendicular to the radius FO. If QP is perpendicular to SO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule 1. So, in the next step, we did a construction. That is to say, from this point B, we draw perpendicular on the radius OS. Again, from point B, we draw perpendicular on the radius OS. So, this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We defined the touching point of the perpendicular from point B and the radius OS as M. So, inside this quadrangle BQSM, we have 1, 2 rectangles. Therefore, the fourth angle must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. In order to complete the sum of the angles inside quadrangle BQSM to 360 degrees, the missing fourth angle, this missing fourth angle must be equal to 90 degrees in its side. So inside quadrangle BQSM we have 4 right angles, and we know that any quadrangle that has 4 right angles must be at least a rectangle if not a square. So we will relate to this quadrangle BQSM as a rectangle, and we also know that the opposite sides of a rectangle are equal to each other. So in rectangle BQMS, side BQ must be equal to the opposite side MS. But BQ equals to 3, therefore MS must be also equal to 3 units in its length. And we also have the rule that the opposite sides of a rectangle are parallel to each other. That is to say, side BQ and rectangle BQMS must be parallel to side MS. Okay, again, in rectangle BMQS, side BQ must be parallel to the opposite side MS. So, MS is parallel to BQ. But MS, this line segment MS is part of OS. It's part of OS, that is the radius of this quarter circle. So OS is a radius, it is absolutely a straight line. And we know that part of the straight line OS is parallel, that is actually MS, is parallel to BQ. So if a part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. And because of the fact that MS is parallel to BQ, therefore OS must be also parallel to BQ. So we found out that OS is parallel to BQ, and therefore quadrangle OBQS has one pair of parallel lines. That is to say, OS is parallel to BQ. Therefore, this quadrangle with one pair of parallel lines, it is a trapezoid. Because the definition of a trapezoid is a quadrilateral with one pair of parallel lines. So quadrilateral OBQS is a trapezoid. Again, quadrilateral OBQS is a trapezoid because it has one pair of parallel lines. And here, what is the length of OM? The length of line segment OM. Here we have MS is free. MS is free, and OS is the radius of the circle, that is X. So OS minus MS, OS minus MS equals to OM. Therefore OM equals to X minus 3. Okay, so OM equals to X minus 3. Again, OM is OS minus MS, so OM equals to OS, that is X, minus MS, that is 3. So it can be found out that OM equals to X minus 3. And in the next step, we did the construction, that is to say from point A, we do perpendicular on OS. Again, from point A, we do perpendicular on OS. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We defined the touching point of the perpendicular from point A and OS as point SN. So inside this quadrilateral NSPQ, we have 1, 2, 3 rectangles, therefore the fourth angle must be also equal to 90 degrees. So this quadrilateral ANSP with 4 right angles must be at least a rectangle if not a square. So we relate to this quadrilateral as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, rectangle ANSP, side AP must be equal to the opposite side NS. But AP equals to 6, therefore NS must be also equal to 6 units in its length. So NS is 6, MS is 3, therefore the missing side NM must be equal to NS minus NM. NS is 6, NM is 3, therefore NS minus NM is 6 minus 3, that is 3. So you can really find out that NM, the line segment NM, the small line segment NM equals to 3 units in its length. Okay? And we also have the rule that the opposite sides of a rectangle are parallel to each other. So in rectangle APSN, side AP must be parallel to the opposite side NS. Again, side AP must be parallel to the opposite side NS in rectangle APSN. AP must be parallel to SN in rectangle APSN according to the rule that the opposite sides of a rectangle are parallel to each other. So we know that AP is parallel to SN, but SN, line segment SN, is part of the straight line OS. So if a straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. Therefore OS must be also parallel to AP, because NS is part of OS. And if OS is parallel to AP, if NS is parallel to AP, then OS must be also parallel to AP, because if a part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. Therefore OS must be parallel to AP. So OS must be parallel to AP. So in quadrilateral OSPA, we have one pair of sides that are parallel to each other. That is to say, side OS is parallel to the opposite side AP. Therefore, this quadrilateral OSPA with one pair of parallel lines is a trapezoid. Repeat again, quadrilateral NASP that has one pair of parallel lines is a trapezoid, because that is the definition of a trapezoid. So in conclusion, found out that in the drawing we have two trapezoids that are adjacent to each other. The first trapezoid is trapezoid OBQS, and the second trapezoid is trapezoid OSPA. Okay. Then we defined this angle as alpha. So in the right triangle ONA, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. But we defined 90 degrees minus alpha is beta, therefore this angle equals to beta. Likewise, we have the big angle AOB is a right angle, because AOB is a quarter circle, therefore this angle must be equal to 90 degrees in size. It is a right angle, so angle AOB is a right angle that is equal to 90 degrees. This angle equals to alpha, therefore the missing angle must be equal to 90 degrees minus alpha. Okay, but 90 degrees minus alpha is beta according to our definition. Here 90 degrees minus alpha is beta, so the missing angle equals to beta. So in the orange triangle OMB, this angle equals to beta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta is alpha, therefore the missing angle equals to alpha. So in the next step, we proved that the orange triangle OBM, this is the orange right triangle OBM, is congruent to the blue right triangle OMA. So why those two right triangles are congruent to each other? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles they are both equal to beta, therefore they are equal to each other. And finally, those two angles are both right angles, therefore they are equal to each other. And so all the angles in the orange triangle are equal to all the angles in the blue triangle. In addition, side OB of the orange triangle is the radius of the circle that is equal to x, and it is equal to side OA in the blue triangle that is also the radius of the circle that is equal to the radius of the quarter circle that is equal to x. So we actually found out that the orange triangle is congruent to the blue triangle according to angle side angle rule. What is angle side angle rule? Actually, if you have two angles and the side that included between the two angles in one triangle that are correspondingly equal to two angles and the side that included between those two angles in the second triangle, then the two triangles can go into each other according to angle side angle rule. And from the fact, so the one triangle OMB is congruent to the blue triangle triangle ONA according to angle side angle rule. And from the fact that those two right triangles can go into each other, we will derive that side BM in the orange triangle, side BM in the orange triangle is equals to side ON in the blue triangle. Again, side BM in the orange triangle is equals to side ON in the blue triangle. Okay, so ON is equals to x minus 6. So ON equals to x minus 6. And from this equation, BM equals to ON equals to x minus 6, we will derive that BM also equals to x minus 6. Here, side BM of the orange triangle equals to x minus 6 units in its length. And from the fact that those two triangles can go into each other, we derive that side OM in the orange triangle is equal to side AN in the blue triangle. Side OM in the orange triangle equals to side OM in the orange triangle equals to side AN in the blue triangle. And ON equals to x minus 3. Again, OM equals to x minus 3. OM equals to x minus 3. OM equals to x minus 3. Here. And from this equation, x minus 3 equals to OM equals to AN, we will derive that AN is also equals to x minus 3. Yeah. This side AN of the blue triangle equals to x minus 3 units in its length. In the next step, we implemented the Pythagoras theorem on the right blue triangle, triangle ONA. So I copied the right blue triangle ONA in a new page and we'll implement on it the Pythagoras theorem. So this is the right blue triangle ONA that I copied from the original drawing. The hypotenuse OA equals to x, ON equals to x minus 6, and AN equals to x minus 3. Here by PT is a variation for Pythagoras theorem. So according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. So the hypotenuse in the right triangle ONA is OA, therefore the square of the hypotenuse is OA square. It must be equal to ON square plus NA square. Okay, so ON is x, therefore OA is x, therefore OA square is x square, and it equals to ON square. ON is x minus 6, therefore ON square is x minus 6 square, plus NA square. NA is x minus 3, therefore NA square is x minus 3 square. So we found out that x square equals to x minus 6 square plus x minus 3 square. So x square equals to x minus 6 square. X minus 6 square equals to x square plus 6 square, that is 36, minus 2 times 6x, that is minus 12x, plus x minus 3 square. X minus 3 square equals to x square plus 3 square, that is 9, minus 2 times x times 3, that is minus 6x. So we have here x square on both sides of the equation, so x square will get cancelled. After cancelled x square, in this side of the equation we left with 0. That equals to 36 plus 9 is 45, minus 12x minus 6x is minus 18x, and we have here plus x squared. So if we found out that x squared minus 18x plus 45 equals to 0, so we have here a quadratic equation, and the general formula, the general solution for a quadratic equation is x is equals to minus b plus minus square root of b squared minus 4 times ac over 2a. So in our specific quadratic equation, the coefficient a equals to 1, the coefficient b equals to minus 18, and the coefficient c equals to 45. Now we put the data inside the general formula and found out the value of the values of x. So x equals to minus b, b is minus 18, therefore minus b is minus 18, that is 18, plus minus square root of b squared. B is 18, therefore b squared is 18, minus 18 squared, that is 325, minus 4 times a is 1. So 4 times 1 is minus 4 times 1 is minus 4, times c, that is 45. So minus 4 times 45 is minus 180. So we found out that x equals to 18 plus minus square root of 324 minus 180 over 2. 324 minus 120 is 144. So inside the brackets we left only with 144. Okay, again inside the bracket we left only with 144. So x equals to 18 plus minus square root of 144 over 2. So x equals to 18 plus minus the square root of 124 is 12 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to 18 plus 12, that is 30, and 30 over 2 is 15. So x equals to 15 is the first solution. The second solution for x is that x equals to 18 minus 12, that is 6, and 6 over 2 is 3. So x equals to 3 units in its length. Okay. And this solution x equals to 3 is incorrect. Why? Because in the drawing we have this line segment BM equals to x minus 6 units in its length. So BM equals to x minus 6, so BM is a length, and as a length it must be a positive number. That is to say, BM that is equals to x minus 6 must be positive. That is to say, it must be greater than 0. So x minus 6 greater than 0, we added 6 to this inequality and found out that x must be greater than 6. So x must be greater than 6, and x equals to 3 is less than 6. So this solution is an incorrect solution, and we left only with the first solution that is possible for x, that is to say x equals to 15 units. That is to say, the radius of the quarter circle x equals to 15 units in its length. And what is the area of the green shape? The area of this green shape is equals to the area of this this shape in total. So the area of this shape in total minus the area of the quarter circle OBA will give us exactly the area of the green shape. Again, the area of all the shape here in total minus the area of quarter circle OBA will give us the area of the green shape. Repeat again, the area of the green shape in total it is equals to the area of this all this shape. What is the area of this shape? This shape consists of two trapezoids. The first trapezoid is trapezoid OBQS. So it is the area of trapezoid OBQS plus the area of the second trapezoid, trapezoid OSPA. OSPA plus the area of the second trapezoid OSPA. And so the sum of the areas of the two trapezoids, will give us in total the area of this shape. So the area of this big shape minus the area of this quarter circle OBA will give us exactly the area of the green shape. And what is the area of the quarter circle? The area of the quarter circle equals to the area of the circle that is pi x squared, because x is the radius. And when we will divide the area of the circle by 4, we get the area of the quarter circle. So it is pi x squared minus 4. So what is the area of this trapezoid OBQS? We know that the area of any trapezoid equals to the sum of its bases times the height over 2. The first base is OS, that is x, that is equals to 15. The second base is BQ. The bases of a trapezoid is the sides that are parallel to each other. So it is OS and BQ. OS is 15, BQ is 3. So it is the sums of the two bases times the height. The height is MB, that is x minus 6. So here x is 15, so x minus 6 is 15 minus 6, that is 9. So the sum of the bases of this trapezoid OSBQ is OS plus BQ. OS is X, that is 15, plus BQ, that is 3. So 15 plus 3 is 18, and the sum of the bases times the height BQ is X minus 6, that is 15 minus 6, that is 9. So the height is 9 divided by 2. So the area of the trapezoid is the sum of the bases times the height over 2. That is to say, the area of trapezoid OBQS equals to 18 times 9 over 2 plus the area of the other trapezoid OSPA. So the area of trapezoid OSPA equals to the sum of its bases, that is OS. OS is 12 plus AP, that is 6. 12 plus 6 is 18. So the sum of, actually OS equals to 15, it is the radius of the circle, that is X, that is 15, plus AP, that is 6, and 15 plus 6 is 21. So the sum of the bases is 21 times the height. The height is AN, and AN is X minus 3. X is 15, so X minus 3 is 15 minus 3, that is 12. So the height is 12, so it is actually 21 times 12 over 2. Minus the area of this quarter circle OAB. What is the area of the quarter circle OAB? It is the area of the circle, that is pi x squared over 4. Again, the area of the quarter circle is pi x squared over 4. X is 15, therefore x squared is 15 squared, that is 225. So in conclusion, we found out that pi x squared over 4 is 225 pi over 4. So here we have 18 over 2 is 9, and 9 times 9 is 81, plus 12 over 2 is 6, and 6 times 21 is 126, plus the area of the quarter circle, that is 25 pi over 4. Here 81 plus 126 is 207, and 225 pi over 4 is 176.714, and 207 minus 176 minus 7.14 is equals to 30.285 square units. So in conclusion, found out that the area of the green shape equals to 30.285 square units. So repeat again, the area of this green shape is equals to 30.285 square units. Okay, thank you very much.